So, before the break, we were discussing about sustainable hydrogen energy system, and this sustainable hydrogen energy system is the future, because we have to reduce our dependency on hydrocarbons, and hydrogen can fulfill that requirements. We can use hydrogen in internal combustion engine, within the automobile sector also, and in many other fields also. In my opinion, the biggest requirement for the hydrogen is going to be in ammonia sector, and we are going to require the ammonia for fertilizers, and we need fertilizer for our sustainable agriculture production also, because without food we cannot survive, and to have the sustainability of the food and to have high quality of the food, we need fertilizers, and for fertilizers we need ammonia, and to get the ammonia at this moment it is coming from hydrocarbon, right. So, to reduce that hydrocarbon we need to get the green hydrogen. So, the what we have seen very briefly before the break, that how we can use renewable energy technologies for producing the green hydrogen. While discussing, we observed that due to the different operational characteristics of the system components, we need to have appropriate power conditioning devices, and these appropriate power conditioning devices, of course, it is going to require your power electronics knowledge, and those components which we have seen, they need to operate autonomously. So, for that we will need appropriate control mechanism also, and to get that appropriate control mechanism and to have the autonomous operation, we will need continuous data monitoring, and then using physics based machine learning. And before the break I mentioned that the reference level which is required for operating such type of system was missing in that description. So, now I will try to explain you how that missing link of the reference can be avoided by using, let us say for example, DC microgrid architecture or DC bus level. For example, if we take your electric vehicle, within the electric vehicle you have so many different components. For example, electric motors, acceleration, deceleration, braking, so many different components are. So, we cannot, so there is some control mechanism and some reference level which helps to do the autonomous operation of all those components there. Similarly, when we are having this integrated sustainable hydrogen energy system, how we can include the reference level for monitoring, controlling and doing autonomous operation of these components which are having very different operational characteristics. Is it okay? So, now we will start with the step by step. We have this wind turbine here. We discussed that this wind turbine generally for the distributed case, it will be permanent magnet synchronous generator. So, this permanent magnet synchronous generator output is going to be variable voltage, variable frequency. V stands for voltage, F for frequency, and converting it into the appropriate DC level. So, this DC output is going to be there, and I mentioned that when we are converting that excess energy in the form of electrolytic hydrogen through electrolyzer and especially alkaline electrolyzer, okay, we need DC supply. So, let us say here we have alkaline electrolyzer. So, this alkaline, I hope that you are in a position to see from backside. Okay. So, this alkaline electrolyzer, due to its electrochemical reaction, needs DC supply. So, here we will need some power conditioning device, that is a DC-DC converter, to transfer the DC energy to the electrolyzer. For what purpose? To convert that excess electrical energy in the form of electrolytic hydrogen. Now, here we are going to have different DC voltage level, and here we may have different DC voltage level. So, let us say I am making one reference bus here. So, this reference bus, let us say I can call it as a DC bus. Okay. So, this DC bus, in which we will monitor the voltage sustainability, we will monitor DC voltage sustainability. So, this DC voltage sustainability on the DC bus is going to be the key factor. So, the output from the wind turbine, which we converted from AC to DC and supplied it to the DC bus, okay, and this DC bus we are taking as a reference bus, and then we are supplying that DC power through this DC-DC converter to this alkaline electrolyzer. But here in this alkaline electrolyzer, our objective is to produce the hydrogen, which we produced here. Now, what we studied before the break, we have another source into account here. That another source, let us say the solar photovoltaic. We know that solar photovoltaic is a stationary DC output, but the same DC output which we cannot provide to the DC bus, because the DC bus voltage may be different than the voltage which might have been configured through the photovoltaic array also. So, it means that to operate this photovoltaic array, at maximum power point and to have the appropriate DC voltage here, we will need some DC-DC converter, and then that DC-DC converter is going to be connected to the DC bus. Okay. Now, here in this case, it is very clear that we are supplying the energy from these renewable energy sources via through the DC bus to the electrolyzer. Now, there may be another condition into account. We may need to utilize this hydrogen as a fuel for another applications also. So, let us say here we have some load also. If we have some load here, I am just giving very high level diagram. Okay. We will discuss in detail with specific system components with specific control algorithm at later stage. Okay. Do not worry about that. So, this load in most of our condition, it is going to be our AC load, okay, that which we cannot change, and here then we have DC bus. So, we may need to convert that DC into AC also. So, now here you can see that simultaneously we may have the load, simultaneously we may have the input from these renewable energy sources, but with what objective? With the objective of storing the energy in the form of green hydrogen. Now, here we are using renewable energy sources, there is no hydrocarbon. So, this hydrogen we will call it as a green hydrogen or the clean hydrogen. Okay. Now, to do this autonomous operation, okay, that was the objective. To do this autonomous operation, we need some control system here or controller here, because all the time continuously we cannot supply here, because we have the load here also, right. We have to do some analysis, or this controller or some decision maker has to take the decisions, right, for how much energy which we are transferring it to the electrolyzer with reference to the load, with reference to the available primary renewable energy sources are going to be the key factor. Now, this controller, what we are discussing here, it needs to get the continuous information of how much incident wind speed is there. Based on that incident wind speed, we can predict using technical characteristics of the wind turbine for estimating for the next few hours that how much energy is going to be available from the wind turbine. Similarly, from the photovoltaic also, we will need to estimate based on the incident solar radiation and then estimating how much photovoltaic power output is going to be there. Okay. So, here what we discussed in the last lecture or in the yesterday's class, that how we have to predict the photovoltaic array output using the incident solar radiation. And in that incident solar radiation, if you remember, we studied about, or we just briefly discussed about direct radiation, diffuse radiation, ground reflected solar radiation, and that radiation has to be calculated on the panel of the photovoltaics at an appropriate tilt angle. So, that how you will do? We have to use some machine learning techniques for that one, physics based machine learning technique. It means that we need to utilize all those equations there, as well as do the prediction analysis also, and then we have to include the technical characteristics of the photovoltaic, and that information will be required by the controller here. So, here you can see that how this sustainable AI means how we are going to use this machine learning for sustainable technology development. So, here you can see a typical, a specific example. Okay. This is a very good project, and even if someone among you might have not completed the PhD also, can take forward for their PhD work also, because it is going to require lot of efforts, lot of knowledge and lot of integration of different system component operational characteristics and prediction techniques also. So, now here this controller, after getting the information from these different sources here, of course, it has to do the prediction also, right, and for this prediction you can use either machine learning techniques or conventional techniques also, any techniques you can use. Then at the same time we have to consider the load also. So, here this based on the historical data, we have to predict how much the load prediction is going to be there for next 1 hour or maybe 1 day ahead or maybe for few hours, right. That information will be required by this controller. After getting these information, okay, then the duty of this controller is that to develop some output signals. For what purpose? When we want to store or when we want to convert that excess energy with reference to this primary renewable energy sources, with reference to the load, for transferring it to the alkaline electrolyzer. Is it okay? But at the same time, we may need to consider the information at the reference level or at the reference bus energy level information. So, here you can see that the energy level at the DC bus, energy level at the DC bus is going to be changing. Why it is going to be changing? Because this is also intermittent, this is also intermittent, this is also intermittent, right. And due to that all intermittency, naturally the energy level is going to change. Are you able to follow? Because I am trying to give you in a very simple way, just like I mean to the audience they may not have as much technical in depth also. So, just to have more high level, but at the same time to create your interest in such type of work also. Okay? And then of course, you have to consider that how you can think carefully for using some tools, right, for developing control system for such type of system. Now, you might have got the idea that here when we are having intermittent inputs here, intermittent output here, due to that naturally this energy level is going to vary. So, even we are taking this reference DC bus on which this energy level is going to be the dynamic and going to change with reference to the time. So, that may impact the decision which the controller has to make. Correct, because here this is also dynamic, this is also dynamic, this is also dynamic. Due to that, this is also dynamic, and it is going to impact the output which controller has to make. So, to avoid that, on the reference bus or DC bus which we mentioned here, we may need to consider short term energy storage. So, this short term energy storage may help us in defining some levels of energy on this DC bus. So, this short term energy storage going to help for maintaining the sustainability of DC voltage on this DC bus. Based on that, then this controller can make the decision for transferring that excess energy with reference to the load to the electrolyzer. For what purpose? To produce the green hydrogen. Then to transfer that energy from the DC bus to the electrolyzer, even electrolyzer is the DC component, we need here DC-DC converter, boost converter. So, the controlling of the DC-DC converter, PWM switching signals is going to be decided by this controller. right. So, here you can understand that how your electronic engineering background is going to be useful for developing a typical case of green hydrogen energy system. Okay. So, it is very interesting. Now, the next question it comes, when we are supplying that energy to this alkaline electrolyzer, excess energy, but there may be some time we may have the deficit from these renewable energy sources. If suppose the nature is not supporting us, right, in that case, if we are not able to get the appropriate sustainable energy output from this primary renewable energy sources, and we have more load, then of course, we need to stop the operation of this alkaline electrolyzer. So, then this controller has to make the decision in stopping the operation of this alkaline electrolyzer, okay, because we are not getting sufficient energy, and we are talking about the green hydrogen energy system. So, we will come on that point after few minutes, but now when we are talking about the controller of the alkaline electrolyzer, that is a DC-DC converter, which and switching signals have been provided by this, let us say, main controller, maybe I should say, and here I should put some microcontroller. So, then main controller when sends the information to the microcontroller, and then this microcontroller controls the operation of the electrolyzer. So, this alkaline electrolyzer, depending its parameters, operational characteristics, etc., this hydrogen which will be produced here, right, it may be at atmospheric pressure. Okay. So, this atmospheric pressure hydrogen is not going to be good storing. So, we may need to put the compressor for storing the hydrogen which have been produced by the alkaline electrolyzer, and then here you see for this compressor also we need energy, and that energy has to get from this sustainable energy sources. Then only we can say our system is based on sustainable energy technology. So, to get that energy for the compressor, then we have this reference DC level bus. We will take it from the reference DC level. It should come through the microcontroller, and energy will come like this, but its control will come through the microcontroller, because it is going to be a part of alkaline electrolysis system. So, now here you can see that for doing this complete operation, this is the main system component for making the decision, which is collecting all the data. And I think in the machine learning part you are going to study about the machine learning techniques, prediction techniques, regression, k-nearest neighbor equation, or using ANN methods and so on and so forth, right. So, if you use any of the method, that is okay, but to make the decision here, you see we need specific technical characteristics of alkaline electrolyzer, wind turbine, solar photovoltaic system, compressor also, because their energy consumption and energy production from the sources need to be more accurate here, need to be more accurate, not on the gray scale. So, we need more accurate prediction. So, to get the accurate prediction, we have to use physics based machine learning techniques. Okay? And then in that also we need to include the energy consumption of the compressor, then accordingly we can estimate how much after compression, how much hydrogen is going to be produced. Is it okay? Now, when you will do some work on machine learning techniques, you have to consider this maybe as a one example. Is it okay? Now, here we are just focusing on green hydrogen production, and some of you may be aware that hydrogen is highly flammable also. Okay? Hydrogen is highly flammable. So, safety is again very important. Now, with reference to this all system components here, okay, we need to have the information how these different components they are operating, at the same time to have information at this main controller about any leakage of the hydrogen. If there is any leakage of the hydrogen, complete system has to be stopped. Because we are engineer, we have to consider from the system engineering point of view, and safety should be on the top priority, because health and safety is on top priority. So, here we will have some sensors. So, this hydrogen detector sensors, it will be continuously monitored, and the information will be taken by this controller. And if suppose there is any leakage of the hydrogen at any level, whether at the alkaline electrolyzer production level, maybe at the compressor level, or maybe at the storing level, So, all those information basically through these hydrogen detector sensors need to be integrated in this controller for making the decision for stopping the operation of the system completely. Is it okay? Now, coming back to this point here, we have this hydrogen production or compressed form of the hydrogen, and we are talking about the green hydrogen. Renewable energy output is going to be the intermittent, we need to predict. So, here this hydrogen production prediction is going to be very important from the market supply point of view, because we have to see that how this hydrogen is going to be supplied to the market and at what rate and at what time. Because what we studied earlier, this hydrogen can be used in many sectors. For example, in the process industries, In the process industries, for example, steel industries, we need continuous hydrogen here. Okay. And this hydrogen consumption at this moment, it is coming by natural gas reforming, around 95% hydrogen. But we are moving towards the green hydrogen system, and green hydrogen system means we are utilizing the renewable energy sources. So, the prediction of this hydrogen is very important for the steel production also. So, here you can see that how your machine learning techniques or prediction techniques can be utilized for the supply of sustainable hydrogen for the steel production also. Okay. But now, in my opinion, most of the demand is going to come through ammonia. So, this ammonia we need for fertilizers. So, for fertilizer to have this sustainable ammonia, and we know that for a particular, during a particular season, how much fertilizer consumption is going to be there, right? How much market demand is going to be there, and whether we are is in a position to utilize this green hydrogen, is in a position to make it self-sustainable or not. So, for that, then you have to use some prediction techniques. Without that, then we cannot say that we are going to get the green ammonia. And then this green ammonia when we are utilizing here into the fertilizer, right, then at the same time this ammonia can be used as a carrier from one point to another point, because the transportation of ammonia from one point to another point is a well established technology and commercially available. Okay. So, coming back to the key point here, on this system, like how do you think you can utilize your academic background for some of the part of this system? I know that some of you may be very good in DC-DC converter also, correct? Because you are from the electronics background, many of you? No? Okay. So, some of you may be from the electrical engineering background, some of you may be computer engineering background, yes. So, in computer engineering always we need some mathematics, okay. Without mathematics we cannot do anything, okay. So, let us see if you are having the computer engineering background and your task is to design the controller here or to design the algorithm here, okay. Let us say algorithm is much better word, that how you will design that algorithm. Now, my question is that how you will design the algorithm. Because algorithm development is the key thing, let us say. How you will define or how you will make the flow chart, let us say, of this system and that is going to be used in the main controller, let us say. So you said that, let's say here we have this main component. So here the some of the inputs will be there. So what input you said first? Yes. Yeah, carry on, carry on. I will explain you. Don't worry. Yeah, carry on, carry on. I will rectify it. Don't worry. Yes. Yes. Mm-hmm. Yeah. Any other person who can provide some input? I will explain you. Don't worry. Just your guess, because all of you are the postgraduate engineers now. Any idea? Don't be shy, okay? You have to be reciprocative also, right? Because you have to also provide your thoughts to me, because I am always giving my thoughts to you. So it is also always good to have your inputs to me also, okay? So that I can see that yes, you are in a position to understand some of the part of the sustainable energy system components, and then how we can use that learning. Okay. So what she told to us, that is a really important point, and I will make it more systematic, that one. Okay. What she told, that is a really very good guess. We have wind turbine, solar photovoltaic, and we have to develop the algorithm for the operation. This solar photovoltaic and wind turbine, they are our primary inputs, and of course we have the load also. Okay, and then in between we have some excess energy from these primary sources with reference to the load, and that we want to store in the form of hydrogen. When we are talking about the inputs, so this input, let us say this input, is not static. Good. So when we have this, we have this input that is a time dependent. Here we have the prediction of the wind speed, correct. We will get the prediction of the wind speed. Based on this wind speed prediction, considering technical characteristics of the wind turbine, we are going to get the power output prediction from the wind turbine. There are a lot of models, they are available even in the MATLAB Simulink also. We can provide the input of the wind turbine and providing the characteristics of the wind turbine, we will get the power output. In this case, our wind turbine is variable voltage, variable frequency, but that which you cannot connect here. So, we have the DC output here which we connect here. But now, main input is this. This we will take as a complete one model or one model here, and we got the P output here. Similarly, here we have the solar radiation input. Okay, there are many models or lot of research work have been done here and widely available. Based on that, we can get the PV output production, in which of course, we have to consider the technical characteristics of the photovoltaic system also. Now, this output from photovoltaic and the wind turbine, that is for us the input to this controller. But at the same time, we are having the load also. That load is dynamic, okay, and using some prediction techniques. I will share some models with you also and some papers also, how we can do the predictions of the load, not only with the active power, but with the reactive power also. All that work I have done. So, let us say that prediction is there, that model is there. So, that input is also going to be required, and that input is going to help us in getting the difference of the input power, output power, and that difference we need to provide to the electrolyzer, and then the electrolyzer characteristics will come into account and we will get the hydrogen prediction also. But now, when we are getting this difference here and here, we are going to have the energy level at the DC bus, and this energy level at the DC bus due to these changes is going to be also the dynamic into the nature, and that we have to make, or that we have to keep in sustainable level also, right. We cannot have, there should be some minimum maximum level of the energy at the DC bus, which we need to define in our algorithm. That is a minimum maximum, and then with what objective? To produce maximum hydrogen. With our objective is going to be how much hydrogen maximum is going to be there. But here we have the input variables, right. This is also variable, this is also variable basically, and that we are going to predict with reference to the time, we can say, and with reference to the time, then energy level is also going to be changed. So, on this energy level at the DC bus, we need to define minimum and maximum level also. If it is going below minimum level, not good, and above maximum level, then of course, we have to pump more and more energy to the electrolyzer to put it back to the below the maximum level, and overall maximizing the hydrogen. And as a constant, or as a constant to stop this system, right, we need to put as an input, if suppose there is any leakage of the system should be stopped. So, can you develop one algorithm like this? If I give this task, let us say for doing exercise for half an hour, will you be in a position to develop one algorithm or the flow chart for this process? So, okay. So, do not worry, not need to develop now, but whenever you go back to your home, your work back, you can think like how we can develop that one. Okay, but now you got the idea that if suppose we need to utilize our control system knowledge, algorithm knowledge, electronics knowledge, electrochemical energy conversion knowledge, renewable energy technology knowledge, how we have to integrate together. Then only we can achieve this sustainable hydrogen production. Let us say some of you having computer engineering background, but when they want to develop this algorithm, right, and here you have seen that electrolyzer is one major component here. So, you need to have the input from the electrochemical engineer also, who is very good in building the model or developing the model based on the electrochemical reactions also, because without that you cannot build the model. You need all mathematical equations for that one. And then another thing which you might have seen that not only that, but we have compressor also there, right. So, compressor energy consumption is going to be there. So, that is also going to impact, the energy level here, right. If suppose someone among you may be having mechanical engineering background, let us say, may be in a position to develop the model for the energy consumption of the compressor with reference to this case, right. That also you will need as an input parameter there. So, not only alone the computer engineer can develop the algorithm, but going to require the domain knowledge expertise for integrating all these system components. Similarly, here we have taken the wind turbine and solar photovoltaic also. So, for wind turbine also, now with reference to the change in the technologies, different type of wind turbines they are coming into the market, like doubly fed induction generator, coupled wind turbine, permanent magnet synchronous generator, coupled wind turbine, and now this generator are having the capacity of 3 megawatt, 4 megawatt, 5 megawatt, offshore installation, onshore installation, location, ground conditions, then based on the input data of the wind speed at that particular location, taking into account the operational characteristics of that generator, taking into account power versus speed characteristics, when it is going to be operating at the maximum power point, constant power supply, constant CP, right. All those factors then going to be required here in developing your algorithm for the wind turbine, because in that algorithm wind turbine input is going to be the wind turbine output is going to be as a main factor, because that is a primary supply, and of course, the wind speed prediction is going to be required. So, now here you say, if you want to utilize your knowledge and your expertise with reference to the sustainable technology development, how you have to work in integrated manner. You cannot work alone. That is the beauty of multidiscipline engineering approach. So, in your PhD project, if you are planning to do, always consider to have multidiscipline inputs with only one single domain input. The output may not be sustainable or may not be at useful for such type of projects. Is it okay? I hope that you learn some new thing, because that is the main objective here. Okay, because we cannot have the knowledge of all the. If someone asks me, let's say, for a embedded system, so I don't have any expertise, or I don't have not that much knowledge about that one. So it is just like that. Okay. But now, with reference to the objective of this GAN course, I am trying my best to share my experience of more than 3 decades of working on these projects, and I want to help you so that you can become a good professional engineers, good global citizens, and contribute effectively by using your technical knowledge for the sustainable development of the society. Because here you see, I mean, we are talking about green hydrogen system. Of course, lot of economics are involved, lot of industries are involved, and many things are there. Of course, everyone is making the profit, but overall, we are looking that we are reducing the CO2 emission, and reduction of the CO2 emission is required for our survival also. So, our objective is to have better life for us and for our next generation, and it will be possible when we are going to do, or when we are going to do the practices of sustainability. Then only our next generation, they can survive very good in this, on this earth basically, right. So, we have to see that how we are going to get the knowledge and how we are going to teach our students also, right, so that they can also contribute effectively for our society.